And I'm really honored to be here because I attended the machine learning workshop in Valencia a few years ago, and I've been using BigML before then because it's a really good way to introduce business school students who may not necessarily be interested in coding or feature engineering into machine learning. And from there, they start their machine learning journey, but they can go on much further. So what I try to do is not necessarily to give students a project to do with machine learning, but really how you can incorporate ML into existing academic units. Because if you think about it, students always have problems that they want solved. So it's much easier to introduce ML as a way of solving problems that they already have, rather than to find a problem that they can solve with ML. So one of the larger units that I teach is called Project Investigation and Systems Method. I have 330 students, and they're required to come up with a project as well as think of how it would be evaluated and explained to practitioners. And I tend to use this at multiple stages, but the first introduction tends to be in the early stage where they're trying to figure out what problem they want to solve and how they should explore the academic literature to help them with that process. So quick overview of what I'll talk about today: why review the literature, identifying a research gap, creating research questions, where can we get text data from if you don't code, how we use topic models, the process, and next steps. So depending on the discipline that you're in, there's more or less emphasis placed on the academic literature. But for people who are new to a problem, like students, or even as a practitioner, if you're exploring an area for the first time, you don't have much domain knowledge, there's some value in exploring the academic literature to help you see if you're answering the questions. One, am I answering the right question? And two, am I answering the right question in the right way? Now, for most of us, including myself, if you look at the flowchart off to your right, we tend to start somewhere in the middle. What is the preferred solution? Because we see something that sparked our interest, we go on BigML, we see a use case, we go online, we see somebody else has done something, and then we apply the solution to the problem we think we have. It's always useful to take a step back and spend a bit more time confirming what the actual problem is, because we may have an assumed problem, but there's no evidence for the assumed problem, or it's not sufficiently clear. So we want to spend a bit more time clarifying what exactly the problem is before we proceed to the solution. And that holds true in academia as well as in industry, that maybe we could spend a bit more time focusing on the problem than choosing a solution or algorithm or letting OptiML solve for us. And why BigML is useful for this? It's because it's intuitive. It's for students who are used to using browser-based packages. It's pretty straightforward. No code is required. I do R for some social network analysis things, but teaching R to students is hard work at the best of times. It's browser-based, so we have to also think of the learning environment in which our students are based, and some students don't have their own computers or not sufficiently powerful machines. Some students still do a lot of their work on tablets. Android tablets are quite popular for some students. So if you don't have a very powerful machine, it's really helpful to have something that's browser-based. Or if you have a computer that you don't control and you can't install software, it's quite helpful. And it's powerful, as you've seen with all the use cases that have been experienced before. There's quite a wide range of things you can do with BigML. Now, while business schools need to adopt machine learning also needs, practitioners need to get an idea as to what happens in business schools. Now, in some domains of business and management, when you're putting together a research paper for an assignment or for an academic journal, or you're doing a dissertation, PhD thesis, that sort of stuff, the contribution we expect, what is called a constructive contribution, is both to theory and to practice. Now, a lot of people who come into machine learning are very practice oriented, which is fine. But if you're in a business school and you're working in certain management domains, like mine, for example, project management or marketing or other areas, there is a requirement to show how your work extends existing theory, which means you have to read the academic literature. You can't ignore it. And there's some gaps that students typically find when they do their reading, that there's a problem, but research has ignored aspects of it, so that's neglect. There's theoretical ideas, but nobody's done any empirical work. In other words, nobody's talked to a company or looked at people, or even a research overview. There's quite a lot of work done in simply summarizing the literature. Some in the more structured cases, systematic literature reviews, but research summaries are quite helpful. And one of the ways in which you try to structure that is this acronym PICOC, which I'll explain a bit later. But you want to understand the context in which you are trying to define and refine your problem, because the geographical, professional, organizational context might perform or provide radically different problems and radically different ways of describing the same problem. And questions that make sense in your context, let's say I'm working for the health service, may not necessarily make sense in a retail industry. So, for example, a typical thing that I get in operations and systems management is why our process is slow. You get that from companies. There are many answers to that. That could be process design. That could be benchmarking. We are slow as compared to other people. Or that could be resilience. There's a disruption and we're slow to respond. So formulating your PICOC is quite helpful. And questions you want to think about the population. Who are the sort of people, the entity that will be affected by the outcome of your research question? The intervention, what or how? What are you going to do? Is it a technique, a factor, the independent variables if you're doing statistic? The comparisons compared to what? What are the alternatives? The outcome, what are you trying to accomplish, improve, or change? And what's the goal? What's the purpose? And the context, and what type of organizational circumstances? And to clarify on the next slide a bit, so here's an example, one that pops up quite often now since everybody's on lockdown, is remote working effective for professionals? Does that work? But that's a vague question. And we can improve that by taking into account the population, because if you're a construction manager who have to go out on site, remote working might not be effective for you. So the effect could be different for construction management of data analysts who may not need to go into an office of any kind. The intervention needs to be clarified because for some people, remote working means home working. For others, remote working means off-site, which could be at customer site. Comparison, it might be different for different management schemes if you're in an agile type environment versus a traditional type environment. The idea of effective needs to be defined because the effect on performance, in other words, how quickly you do a given task, might be different to the effect on employee satisfaction. Employees might be happy working from home. And the context, of course, could be different for business school, just for hotel. So when you establish that, you can determine whether academic evidence is relevant or applicable to your context. First thing you want to do is to structure a search of the academic literature, get some clear research terms. You want to determine the first two important terms. And for most people, the intervention, what's the management technique or the factor you wish to explore is probably more important. And the outcome, business performance might be the most useful things to structure your search. So remote working, business performance. You might want to find alternative and related terms, in other words, to broaden your search if you don't find enough resources in your initial search of academic literature. And, just to help you, the academic literature can help you confirm the cause of the problem because other people might have looked at it. You might get some interested and in some cases some surprising relationships uncovered between the cause, the problem, and organizational issues. They may not be a linear or direct cause and effect relationship. And if you get enough research being done in your organizational context, you can see if any evidence is generalizable to your specific context. Now, for a lot of my students, they don't code. Now, for many people on this call, they're developers, they work in organizations, they've got resources who can find and process things for them. But for my students, they don't code. And I tend to deliver these classes in 1 hour segments, so I can't spend too much time, 3 or 4 weeks, getting to grips with how you would get text data out of an API. So if you are looking for academic abstracts, there's Scopus. If you work at a university, that's accessible. You can export up to 2,000 abstracts at a time. It comes in a nicely formatted CSV, so not too much wrangling is required. It can go straight into BigML. Web of Science, same thing, but I think Web of Science only allows you 1,000 abstracts at a time, so you export multiple, put it together as one file, then put it into BigML. Connected papers. Now, if you don't find many papers in your first search, you can use connected papers, and that uses graph theory to help you find other related research that may cite the same sources, but not necessarily use the same keywords or the same search term. So it allows you to broaden your search, and then it exports it as a .bib file that you can get a file converter for into a CSV, and then again straight into BigML. If you're not associated with academia at all and you still want academic abstracts, there's Publish or Perish, that's softwareenhancing.com. It allows you to do 10,000 API call, 10,000 fields per month from Microsoft Academic, which would give you academic abstracts. So it's a useful place to start if you're not associated with the university at all, or your university doesn't subscribe to Scopus or Web of Science. You could download Publish or Perish. You do have to download it though, so you need your permissions on your own computer. But you can do the search, you get a nicely formatted CSV, it goes straight into BigML. If you're doing social media, slightly OT, but if you're doing social media and you don't code, there's Netlytic, free plans for students and academics. You can pay a bit extra for larger data sets if you want to. There's Facepager if you want to do stuff on Facebook, Twitter, Reddit. And if you're looking at general web scraping, and I've got students who look at, for example, reviews on TripAdvisor, or who look at job ads and things like indeed.co.uk, because they're looking at competencies of managers and management, and the way they explore that is by taking a large number of job advertisements and then doing a little bit of text mining on them. You can use Octoparse. That allows you 10,000 fields per month, and you can pay a bit for more if you wanted to. Again, if you work in an organization, you've got resources, that's fine. If you don't and you still want to get involved, it's not difficult to do this, and no, you don't need to learn to code. Now, if you're doing this within a university, there's a couple of points you want to note. Ensure that you have ethical approval from institution before beginning web scraping, and ensure that you're operating within the platform's rules, especially if you're planning to publish it or you're planning to write it up as a student's assignment and so on. For purposes of today, for exploratory work or for understanding how to use the tools, it's fine. But if you're planning to do this for your dissertation or for some bit of published work, you will need ethical approval. So that's the background. And now why topic modeling? Because it allows us to categorize text. There are many options. You can do manual text categorization. That's resource intensive. Can't get that done in an hour. You can use dictionary based either manually or automatically, but then that does require a dictionary to exist for the terms that you want. Supervised machine learning does require labeled data and can be used in some cases. But if you want to get students started quickly, without too much messing about, we can use unsupervised machine learning to get us some quick insights as to the nature of the topics examined in our data. And in this case, using topic modeling. Now, topic modeling has advantages and disadvantages, but the advantages far outweigh the disadvantages for exploratory work. The advantages, it's automated, so it's fast, not resource intensive. The results are reproducible, so I can give the data set to somebody else, and we are sharing the data set, and you should get similar results. And it works with large scale heterogeneous texts, not a problem for topic modeling. The disadvantage is that the researcher will have to interpret categorizations if we're using this at the exploratory phase. If we're using it to feed into another type of predictive model, perhaps not, but if in this case, I use it with students to explore the literature, so we do have to interpret the categorizations manually. And just a quick one on LDA for those who aren't familiar, latent Richard analysis. We assume that they are documents. So we have all documents have a fixed set of topics, and each document has these topics in different proportions, from not mentioning it at all, 0% to 100% exclusively mention it. And each topic is a combination of words who have their own percentage allocation. But we can just show you that slightly later on. So when we're interpreting topic models, and I did say that topic models have to be interpreted manually, so you do want to think in advance when you get the findings back, what do I do with them if I'm interpreting them manually? So there's some questions to ask. The first one, are individual topics meaningful, interpretable, coherent, and useful? So when the topics come back from BigML, do these topics make sense? Can I interpret them in light of my initial research question, whatever it might be? Are these topics coherent? In other words, are these topics talking about the same concept in the same way? And are they useful? Because you can get things that meet the first three categories, but of no use to your research. So academic papers, for example, you get quite a few, you do your initial topic modeling, you might get things like publishers' names being mentioned. And that's not really of any use to your research unless you're looking at publishers. And so that's the first stage on individual topics. And then the next stage, once you're happy with the individual topics, assignment to topics of topics to documents, meaningful, appropriate, and useful. So after we're sure the individual topics, we then look at the topics assignment to the documents, and is that meaningful, appropriate, and useful? And if it's not, we may need to repeat the topic model. And there are some typical topic modeling problems that you may encounter, especially if you're doing this for the first time. Too many common words or too many specific words. So like names of publishers I mentioned before coming in that you may need to eliminate from your study. Mixed topics that contain more than one topic and need to be split. So it's talking about two different concepts in the same topics. So you might want to increase the number of topics to split it. Identical topics where two topics are proposed are the same. You might want to reduce the number of topics to combine them. And you've got a nonsensical topic if documents have the same structural pattern. So if you're doing, again, academic reviews, you may see methods and techniques as coming up over and over because that term might be used over and over in academic abstracts. So really simplified process. I did this live a few weeks ago with some students. So they wanted to look at customer segmentations. That was a P and the I. Sorry, the I and the C. Sorry. We did a Scopus search for abstracts. We then uploaded those abstracts into BigML. We did a little bit of text pre-processing and source configuration because we only did topic modeling on the abstracts, nothing else. And we did some topic modeling experiments in order to produce the outcomes that we've got. So pre-processing, we did some stop word elimination to remove common words, words not useful for the study. And we did some revisiting that after initial experiments, stemming, tokenizing, and we used trigrams in this case because this was a quick overview analysis. Now this entire process takes less than an hour from data collection to finalize review of topic models. So you can do this very, very quickly, embedded within an existing class. So we set up a quick table and I adapted that from these guys and I encourage students to do that as well. So you think of what parameters you might want to change and then you record as you go along. So, initial searches were just that we let BigML decide the number of topics. You start with the max number of terms and max n-grams, and then you come down. You can come down in n-grams, or you can come down in number of words, depending on what's happened. Other settings that we use, we aggressively remove stop words, case sensitive was off, and we use sensor sampling. We use all of the abstracts, not just a subset of them, not a sample. So initial experiment, these were the results. So that's the topics that were presented by BigML, gave us 40 topics. And we found that there were too many specific words. So you look at the topics overview, there's one, Emerald Publishing. So if I go to the previous screen, that's that. That's not a topic that was useful to the students studying customer segmentation, so we didn't bother with that. We added those to the stop word exclusion list so we could remove them. So too many specific words. So we ran it again, experiment 2. We increased the number of terms because the student wanted to see if that would give us better topics. Seemed to work a bit more. We get more things that were useful. A few more publishers and they were not as bad. So that's the findings. Just a summary, of course. We didn't show 20 space wouldn't permit, but you can, of course, repeat this yourself with the data set. So things like latent class and so on. So this is more of a methodological thing talking about options that are used to analyze customer segmentation. The other one is mostly on tourism, but there's still some words in it that we didn't really want. So cognizant communication, for example, is a publisher. That's not really useful for what the student was trying to do. And here we had a mix of methodologies and things like service attributes, which we didn't necessarily want in a methodology topic. So repeat it again, experiment 3. So you have the topics being presented again there. And these are the results that we've got, and the student was happy enough with those. So here's a methodology focused at the numbers that decide here, the word percentages, so the words per topic. So these aren't great for the first two, but for the last one for factor analysis, it's not too bad given the size of the data set. Logic model, and then there's one on data mining, which talks mostly about using machine learning to do customer segmentation. And the last one, factor analysis, mostly using that. So we follow the iterative approach. So once the student was happy with the topics, the next step was to do an inspection to see if the topic assignments were useful for the abstracts. So created a batch topic distribution. You can export that as a CSV, and then you can do an inspection looking at the topics and the abstracts to see if those were of value to the student. And again, since this was exploratory, the student was kind of happy with it. I went on from there. But of course, you could go back and revisit if you weren't happy with the assignment of topics to the abstracts. We then you could repeat this process again if you had a specific topic that you wanted to get in depth with. Academic papers have, for example, taken these topics, downloaded them, taken the papers, split the papers into paragraph, and then build another topic model of that, so you can get much more detail in a single subcategory. Or we can use topic modeling, as the previous speakers did, as an input for additional predictive models that we can use there. So that's most of my presentation, and the whole idea is really that how you can introduce topic modeling as part of an existing course, something that students are already doing. So they don't think that they're coming to a course of machine learning. They may not sign up for that. Some students might, some might not. But you sign up for a course on research methods, things that they've got to do anyway. And then BigML and topic modeling is a way of helping them solve a problem that they already have. And from then, the sky's the limit. They could continue taking the same data set, adding more features to it, do logistic regression or any of the things that we've seen described before. They can go on to take some of their other data sets, so SPSS or things from Kaggle or open data, and explore it using other machine learning techniques. But the whole point is to get them started, just to get them interested that this is something you can use to solve a problem that you have. So you don't have to look for a problem for BigML to solve. Use BigML to solve a problem that you have.